Hi, everybody. Just a quick intro. I'm Scott Germaise. I'm a digital product management strategist. I've got a record of scaling products from content and commerce through healthcare, along with some Web3 experience. I've had several great startup to exit outcomes, several through patents along the way. Right now, I'm consulting with a few different startups, one of which is headed towards using LLMs for content generation. My primary experience with ML is with image recognition, some chatbot design for health tech, and some natural language queries for large data sets. Like a lot of you, I'm focusing more on LLMs these days. So let's talk about what our goals are for today. Let me get to the next screen here. This is Introduction to ML AI Project Performance Metrics. Just so you guys know, I am certainly not going to read every screen, but for accessibility reasons and because we never know how people are consuming the presentation, I probably will read some of the core ideas off of each one, but then we'll just be speaking to them. These materials are going to be available to you later. And part of the goal here is to come away with a basic understanding of evaluation metrics for ML and AI models and have a great starting place for going deeper in our own self-study. As part of this course, for those of you in one of the cohorts, as you know, one of the goals is to give you a deep understanding of each of the content areas, but at the same time, really give you a starting place for learning more. There's a great deal of information here. There's way more than we're going to cover in one session here. This would take weeks, even a whole semester, maybe a year. So this is about a lot what your data analysts are going to do. So we're going to go over the product manager concerns from your perspective, a taxonomy, an overview of the specific metric types for this particular product area, some of the common metrics, and we're going to get into some real world practice. We're going to see exactly how some of these things work. We'll talk about a couple of observability platforms, which is the fancy way of just saying analytics for ML and AI. And then we'll finish up with some conclusions and questions. I will try to keep a little bit of an eye on the chat window to see if there's any questions, but I can't guarantee that I'm going to be able to do that the whole time. So let me go back for just a moment. Product management concerns in particular. Where should we be focusing our time? As product managers, we're kind of interesting. Well, I think we're very interesting, right? We come from a wide variety of angles. Some of us started from the business side. A lot of us came from coding of some sort and moved into product management for whatever reasons, some from design. So because you're never sure exactly who you're talking to in these presentations, we want to make sure we go from the high level down to make sure everybody's up to speed on where we're at. At a strategic level, we're primarily concerned with business outcomes. When all said and done, that's what we're trying to accomplish. And there's several different categories of analytics that are going to impact those goals. Most of us work at a tactical level, depending on our level. You could be a CPO, you could be a chief product officer, or you could be a technical product manager. As you know, in this industry, especially in digital, product management can mean many, many different things. And a lot of that has to do with the level of depth you're going to have as an individual contributor. At a tactical level, our model performance is going to roll up to these higher level KPIs, the same as it does for web and mobile and other analytics. The fundamental question on the right side here, we talk about how deep do we go? And this is going to depend on our role, and that's the level and the task. And regardless of our direct involvement, we're going to want to ensure somebody is appropriately tasked. And again, when we talk about how deep, this is the classic question for product management, especially for digital. People ask, well, do I need to learn to code? And the answer is probably not, but it certainly depends. If you're a technical product manager and you're building out and defining APIs for blockchain or something like that, chances are you've got some sort of back-end or front-end experience with code. You're familiar with it, you know what's going on. You could come from the pure business side. In some large corporations, the entire web and mobile area might just be one line item on a spreadsheet. And all that senior person cares about is, are you moving my needles? You all, we all, are probably someplace in between. So how deep you go with some of the material we're going to go over today is going to be up to you and what your use cases are. Now, here's what seems to be true no matter what. This is the classic product manager reality. You might not own this task. Maybe it's a direct report, or maybe it's being managed by another department, but you had better make sure the boxes get checked. The caption on this cartoon here is, it might not be your issue, but it is your responsibility. The reality is what we've really seen this cartoon look more like is, it might not be your fault, but it is your problem. All right. So somewhere along the way, these metrics, these analytics, regardless of where it is in your product, chances are it impacts what you're doing. Again, it depends on your level of responsibility for the outcomes of the product. So what about a taxonomy? Taxonomy is basically a categorization. Where does ML and AI analytics fit? Sticking with the idea that I don't necessarily know for these sessions where you're all coming from, let's look at general product management analytics for a moment, and then we'll figure out where the taxonomy for MLI and AI fits into this. You've probably seen this before. If not, if this is new to you, this is another place you should be diving into. But generally speaking, we've got these categories of analytics. We have our business and marketing analytics, our product specific analytics, some technical and operational analytics, and then maybe monitoring. Now, those latter two might not be our concerns at all, though they impact us as does anything else. When we talk about business and marketing, this is at a high level. How's the business doing? Are we achieving our desired outcomes? These are things like revenue, market penetration. You may have heard of HEART frameworks or startup metrics for pirates like R, which is acquisition activation. Certainly, we always have CAC and LTV, customer acquisition costs, and lifetime value of customers. At the product level, this is where most of us live most of the time, and that's what we're going to be getting into for ML and AI in just a few moments. This is for functional product managers, a lot of teams and individual contributors. So these metrics might be known as drivers or signposts, indirect levers. They may be predictive, maybe not. So these could be both leading or lagging indicators, depending on how you define them. And this is everything from our traditional page usage to where people fall off along different conversion funnels, say, for example, for e-commerce. Next is technical and operational. We may not have to deal with this much, hardly at all, but there's some places where there's a lot of overlap with product. So for example, web page load times and things of this nature. And this is typically going to be done by either IT or DevOps or whatever that division might be referred to in your company. Now, we might not have much of anything to do at all with this, but we all know that product performance very much depends on things like web page load time. In terms of technical and monitoring, heartbeat systems to make sure servers are up. Generally speaking, we don't have to care about that at all. Although, as crisis PR managers, we are all the time anyway. If something goes down, chances are we have to deal with it. So where does ML and AI performance metrics fit into this? Typically, it's at the IC at the individual contributor level from product on down. And let's look at what that looks like. So the measurements that we have at our disposal generally fall into two different categories, and these are performance metrics and business success metrics. For performance metrics, these are very much machine learning and AI specific. These involve data quality, classification metrics, regression metrics, clustering, performance and efficiency, large language models, and convolutional neural networks. On the business side, this is more classic. This is user experience, operating, business performance, and suitability to task. Now, suitability to task isn't necessarily an official category. It's not something you necessarily see in other literature. It's something I've put in here because in our case, again, we're from all over the place. Some of you may be doing medical AI. Some of you may be doing fraud detection for e-commerce. Some of you may be doing advertising optimization. It could be all over the place. So somewhere along the way, is there some sort of specific metrics for you that are suitable for the task at hand? Those are not necessarily ML and AI specific, but they're related to your product. So we're including them here, and we'll look at them in another document in a moment. So why do we have so many subcategories? And don't worry, as I said, we're not going to read every single slide here. This is for you to consume afterwards. I just put these things in here as examples. We have a wide variety of algorithms for our use cases because the mathematics for some of these metrics to evaluate them differs, though there is overlap. And again, it all depends on what your level you're at as to how deep you're going to go with this. This session that we're doing today, this might be the deepest you ever need to go here. You might say, okay, I understand that somebody needs to do that task. It's not me. I'm glad I know about it. Never going to touch it again. Others of you, however, might be diving in much deeper because if you're an individual contributor and you're actually writing the stories or the PRD, the product requirements document, however you're doing requirements in your shop, you may need to go deeper here because the definition of done or what constitutes success might very well hinge on what some of these metrics look like. So just as an example, we have logistic regression. These are linear models, and let's say there's multiple types of regression analysis, of course, but let's say we're just doing a simple binary classification. So something like if email is spam is not, or is spam or not, or something is fraud or not. And again, these other examples here are just to give you a sense of the different subcategories that each might have their own particular class of analytics for ML and AI. Now, When we get into the specifics, what we're certainly not going to do today is go over dozens of KPIs and metrics in depth. Instead, we're going to focus on a top few for common use cases. In the course literature, what we're going to do is put in a link to this document here, which again, we're not going to go over in depth, but what this has is this has dozens of analytics for you. Let me scroll down quickly and just show you what's in here. So for each of these things, we're going to tell you what the metric is, what a typical target might be, some notes that define what this thing is, and then some references so you can dive as deep as you want. And there are dozens of these things. Each one matches to the taxonomy I discussed earlier, whether it's classification or regression or LLM, right? So you don't have to take notes here in this session, but this will all be available to you, and you can go as deep as you like there. So that's our comprehensive, but not necessarily fully exhausted list of metrics. Now, before I get into some of the details here, let's talk again about metrics and KPIs. Metrics are quantifiable measurements. It's basically a number. And again, I always go back to the classic page view example because it's just so simple, even though page views increasingly are not necessarily a great indicator of engagement. We have so many others now. But these are simple numbers that provide an objective piece of data that you use to analyze your product. So what's the difference between that and a key performance indicator? Possibly nothing. You might use the same number as a KPI. It's really how you think about it. A KPI is a more strategic-oriented number. A lot of times I think of KPIs as often as ratios. It's not a simple number. It's more like something like, how did we do month over month in terms of percentage increase in our revenue? Or maybe it's month over month as compared to last year. It's basically a lot of times a feature engineered number that's a ratio of some sort. It's how are we doing? And it relates back to strategy. So you have to pick which of these things are going to be most important. Or perhaps someone else has chosen this for you and you've got to manage that number. Okay. Oops, hold on just a second, please. All right. So in the end, only two metrics really matter. And this is, again, some of this is just my opinion throwing this out there, and you can take that for what it is. Suitability test, we talked about that a little bit. And this is what you're actually trying to do. So this might be the percent of customer service tickets fully automated or that run faster with reps, or accurate and useful recommendations for products and services. This is always going to depend on you. So you're always going to have to figure that out for yourself in the end. And then there's costs and P&L. Once again, you as a product manager might be coming at this from a variety of different places. Some of you may be feature focused and internally focused as product owners, as opposed to more externally facing product managers or business level product managers, all right? Others of you might own the full P&L for your product, or if not the full P&L, perhaps the budget. And that's going to have impact because your per unit costs, things like queries per second, or in our cases for LLMs, that might be inferences per second, are going to make a difference in your costs. Now, there's other sessions of the PM exercises course where we go into what the costs are, and that's a great session, and you should be looking forward to that. Now, when we're talking about features, functions, benefits for our customers, maybe we're not so much focused on that. We're looking at what value are we going to provide. Maybe some of you don't care at all about what the costs are. That's somebody else's responsibility. One thing you can be sure about, though, is somebody does. So as a product manager, you may or may not own the P&L, but rest assured that someone does. And some of the decisions you make about some of the models that we use or the type of performance we need is going to impact those costs. So let's go over some details of some very specific examples. All right, and there's going to be just a little bit of math here, but nothing heavy. First, let's understand something about something called ground truth. You may have heard of ground truth before. What is it? I'll just read the first paragraph here and then we'll talk about it. In the context of AI and ML analytics, this refers to having accurate, definitive, and reliable data, which serves as a benchmark for evaluating the performance of a machine learning model. So what does this really mean, or why does it matter? If you don't have access to quality, well-labeled ground truth data, how are you possibly going to reliably measure the performance of an AI ML system? Now, I know what some of you might be thinking. Wait a minute. For supervised learning tasks, yes, I've got labeled data, and that's how I might judge things. But what about for LLMs? Or what about for when I'm just doing clustering? Well, there's different types of algorithms. For ground truth, excuse me, we're actually talking about where we have some sort of data. And even in those other categories, we know there's something true about these things. For classification, for example, if something tells you it's a cat and you look at it and it says it's a dog, it's wrong. So there is some sort of ground truth somewhere along the line for most things. Now, as you might imagine, Some of these become a matter of opinion, especially with LLMs and their output, large language models. So let's not miss this insight. This is the important part here. Let's understand that after we test and validate a model, there are aspects of live production data which are effectively not really testable as a practical matter, at least not without having high reliability of known labels. So when we test live production data, especially when it's changing or drifting over time, this becomes a lot more of a probability exercise. And going back to the chat just for a second, we look good here. Can we get the link to the doc? Yeah, all of this, after this session, all of this is going to be put someplace within the Notion if you're part of the course, or elsewhere if you're not. And you'll be able to get to the presentation as well as the other document. So thanks for that question. Let's keep going. So some terminology we're going to see throughout a lot of our different classifications. And if you've done anything with statistics before, you've heard these before. True positives, these are correctly predicted positive instances. True negatives, false positives, and false negatives. And we're going to look at some specific examples of that to clarify this a bit. And to do that, we're going to play a little game here. All of us here in this session, we're going to pretend that we work for a large e-commerce company. Our challenge is that there's some evil product thieves that have been getting away with fake transactions and hurting our business. They've been using false credit cards. They've been sending packages to empty lots and to fake apartment buildings and things like that. And they're costing us a lot of money. So what we did was we built a model that we think is going to detect this. But first, we also created a test set of data. And we've got a total of 1,000 transactions. And yes, the links to the presentations will be provided to everybody either way. I'm not sure if they're going to go into the old Notion site or elsewhere, but they'll definitely be available to you in any case. So, excuse me again. For testing, we're going to have total transactions of 1,000. Only 100 of which, when I say only, that's 10%, so that's maybe a lot, are actually fraudulent, and 900 are legitimate. Now, when I said only, that implies some degree of judgment, doesn't it? And the challenge here is what's going to be good or bad in all of these cases is going to be up to you. In this case, it's an e-commerce example, all right? And it's the economics of your business that are going to determine what's good or bad. If we were doing something medical, though, what percent of x-rays are being diagnosed appropriately, or is a vaccine working or not, things become a lot more serious, and you're ideally going to have significantly different thresholds for what's okay and what's not. So when we run our model, we get a bunch of results, and we get certain predicted fraud, but we also get some predicted legitimate transactions, and we're not necessarily right about all those. So when you consume this presentation a bit more on your own and go through it, you can look at these numbers and you're going to get into these individual data points, such as accuracy. And these, by the way, are all classification metrics. So these fall under the category, the taxonomic category of classification metrics for what we're trying to do. Accuracy is basic performance. Now, a lot of these metrics, accuracy, recall, precision, grew out of search technology. Right now, AI is all the rage, and large language models have brought this to the forefront. But the reality is that machine learning and artificial intelligence is an overnight success, decades in the making. Some of these technologies, some of our ML and AI technologies, and some of these metrics have been around since the 1970s, the 1980s, or longer. Some of these were theoretically around even before we had the computational capability to perform them. So when we look at some of these things, they came from original search, text search and what have you. And of course, some of these things simply can apply to real life as well. So accuracy simply talks about how many correct predictions over total predictions do we have. It's a fairly simple metric. In our case, we're at 93%. Excuse me. Again, whether that's good or bad, it's a judgment for you. Now, these don't necessarily sum up to 100% because they only represent the correctly classified instances. They don't include false positives and false negatives. And let's also think about the fact that right now, for today, we're only looking at some binary examples, not multi-class. So for example, if you were classifying animals and you said, okay, dog, cat, lemur, tiger, whatever, you've got more than two things. So it can become a little bit different, and I'll show you a little bit what those grids look like in a moment. So that's accuracy. And then we're just going to go through a few of these and then a couple for large language models. And then we're going to look at some specific code examples. For precision, this is an important one. This shows us how often an ML model is correct when we're predicting the target, so the positive class. One way to think about this is kind of like how often were we actually right when we thought we were right? So in the real world, you can think about your friends and family or your spouse. You think you're right all the time, but the reality is like, you know what? You thought you were right about that, but you weren't. So precision is basically our true positives when we get it right, divided by our true positives plus our false positives. And in this case, it looks like we're only at about 61.5%. Now, that just feels a little bit low, and that's really because it is. There's a question about confusion matrix, and absolutely, we're going to get into that in a moment. I've got a nice slide for that, or I think it's a nice slide. You can be the judge of that. So some of these metrics are on a precision from 0 to 1, or they're expressed basically as a percentage. And what precision does is it helps us avoid potentially high costs of having false positives. Remember, in our example here, we're trying to catch fraud. But let's think about what happens for a moment. Let's say we have 50 false positives. There's 50 times we thought there was fraud, but there wasn't. Ostensibly, we're going to do something about that, right? We're not just going to count it. We're going to say, okay, we think this is fraud. What are we going to do? We might ask for a different credit card or payment method. We might ask for more KYC, know your customer information about that person, or address information. The problem there is what? Somebody might abandon us. Now, if this is a product that's critical to somebody, they'll go through that. But if it's just another place to buy a commodity item, they're gone. They're going to go to a competitor in one click. So precision becomes important for that reason. And we have to be aware that if we increase precision, we might reduce accuracy and recall. So let's move on to recall. So recall is tightly coupled to precision and accuracy. This shows us how well our model can find the objects of our target class, that is the positive class. So this is the true positives over the true positives plus the false negatives. In our case, that's 80%. Now, some of us might think that's not bad, and maybe that's okay. You might also hear recall known as sensitivity. It's the true positive rate. So it might be something like, did we detect a disease in the case of something like medical? So this can be a really important metric. Once again, you need to decide what's the balance, what numbers are you looking for? And somebody had asked about confusion matrix. I'll get to that in just a moment. So let's summarize our scenario here. We maybe have a somewhat decent accuracy in recall, and we're arguably doing fairly well in predicting fraud. The question is, could we do better? So this has to do with why. Why are we tracking these metrics at all? It's because we want our models to do well, because this is going to manifest itself in the real world with what our websites do, or what our mobile apps do, or what our IoT does, or as we get more and more into ML and AI. Remember, one of the advanced parts of AI these days is the idea of agency or agentic tools. That is, tools that work on our behalf. Again, people have been working on this sort of thing for decades, but only now it's looking like it's becoming more and more real. So we need to get some of these things right. What can we do to fix our problems when we have bad metrics or bad models? Well, we might adjust a classification threshold. We might enhance feature selection and engineering to incorporate more informative features to help distinguish between fraud and legitimate transactions. We might try other models altogether. Maybe our model is bad. We might use an ensemble model, which uses multiple models. So these are different things we want to do to maintain high recall to continue to identify fraudulent transactions. All right. And again, we're not going to go deeply into this slide. This is something you can read on your own. But I'm trying to, I like to give metaphors in the real world to try to understand these things, because personally, I find that to be a little bit easier. So in terms of recall, if you think of a fire alarm system, recall is kind of like the system's ability to detect any actual fire. So high recall would mean the alarm goes off every time there's a fire, even if maybe it goes off when there isn't one. Whereas precision, as you might have figured out by now, it's kind of like the ability to avoid false alarms. So high precision in this case would mean that when the alarm goes off, there is indeed a fire, and it doesn't go off just for false positives like burnt toast. So recall focuses on not missing positive cases, while precision focuses on ensuring that what you've identified as positive is correct. So a lot of times it's a trade-off between the two. And you may be thinking, for those of you with background in statistics or A/B/N testing, does this feel a little bit like when you reject the null hypothesis, and if you're using a p-value of something like 0.005? Yeah, it's kind of like that. It's kind of like, when do you accept false positives and false negatives and what have you? So there was a question about confusion matrix, and here it is. Another way to consume this type of data is put it all in one place. Now, I've got text here in the boxes, but these could just as easily be numbers. So this is a tabular summary of the performance of a classification model. And this would show you the true positives and true negatives, false positives and false negatives. And one of the things I'm trying to do here in this summary, again, not knowing where some of you guys are coming from, maybe some of you are experts in statistics and you've already heard all these terms before. Some of you may have heard the terms false positive and false negative, or type 1 and type 2 error, but never really tied it together for where it belongs. Somewhere back in history, somebody defined the term type 1 error and attached it to false positive, and type 2 error and being false negative. Not quite sure why. Might as well just call the thing what it is. Either it's a false positive or a false negative. But if you hear the terms type 1 and type 2 and don't recall what they are, just come back here, pull up this chart and take a look. So how do we interpret this? Let's go with the email example. Let's say we were predicting spam. We have an email that we predicted is spam, and it's actually spam. So we predicted it as positively as spam, and it actually was spam. Clearly that falls into the true positive category, okay? So you can, in your mind, come up with your own scenarios and figure out where they would fit in this grid, because that's the kind of thing you're testing for. Now, once again, this is a binary classification we're talking about, when you could have dozens of features that you're putting into a much, much larger grid. And those look a little bit different. They're a lot more complicated. And again, in the other documentation, you can click through and study that further. We also did not go over something called an F1 score, or precision recall curve. That's another score where it basically takes precision and recall and takes an average of, actually, I think it's an average of the harmonic mean of them. But the point is, what it's trying to do is it's trying to balance them together in one score, in one index score, okay? Again, this example for a simple binary classification, fraud versus not fraud, but you could use it for more than 2 classes if you wanted to. Now, we're going to move past the basic classification metrics, and we're going to look at just 2 more specific metrics before I show you some code examples. And this is something called BLUE, Bilingual Evaluation Understudy. And again, some of these things have been around for quite some time. Why? Because we've had language translation for quite a few years. I see there's a lot of different people from a lot of different places in the chat today. And a lot of us have probably used translation tools before, whether it's Google Translate or something else. Certainly a lot of us who have worked overseas, have used these things to great effect, and they're amazing if you travel, especially for business. It used to be many years ago, I was challenging even to get around on the train to figure out what to eat without learning a little bit about languages, especially if they were not non-Latin languages. Say, for example, Cyrillic characters for Russian or Ukrainian, or what have you. So, what this does, let's remember about text. When we talk about statistics in text, we have different tokens at the word level, and a gram or an n-gram is just like a bigram is 2 words, a trigram would be 3 words, and we have a window that goes across the different sections of text, and it relates these things probabilistically to one another. Let's remember that a lot of LLMs, in fact, I think all LLMs, are basically probability machines, and they're looking at what's activating the neurons. So we've got, input neurons, some kind of hidden layer of neurons, and output neurons. And all along the way, what are those neurons doing? They're doing a few things. There's identity neurons that just pass the data along. There's binary neurons that can be a yes or no, and there's sigmoid, which could activate somewhere along the way. But when all said and done, we come out with these probabilities. What this particular metric focuses on is saying, okay, you gave me a corpus of text, let's say a news story, and you asked me to summarize it, or you asked me to come up with a couple of keywords for it, or you asked me to translate something from English into Spanish. How many of the candidate words in the reference, the original corpus, are also in the candidate? And you might think to yourself, that's kind of a gross measure. That might not mean anything that deep. And you'd be right. It's a fairly crude measure, which is why more have come after it. So what would be an example? Let's say I say I want to cross the street. Okay, and in Spanish, that would be something like quiero cruzar la calle. Now, those are almost direct translations. If you were to get into computational linguistics, for example, and look at nouns, verbs, direct objects, and things like that, we could specifically match each of those words. I want, quiero, to cross, cruce the street. We could match those up almost exactly. So that translation should have a high score, given this metric's understanding of what these words mean. Okay, pretty simple one. So let's move on then to something called Roche. Now, this is meant kind of as a replacement for Blue because it's meant to be a little bit more specific. And the acronym here is Recall Oriented Understudy for Gisting Evaluation. Super complicated. I guess somebody just wanted to make up a new acronym because that's what we do. But it really gets down to the word gisting. To get the gist of something, if you're not familiar with that word, just to get the general idea of it. So if you have a really long news story and you just get the general idea of it, it's saying you have the gist of it. So what this does is this takes Blue to another level. So it looks at not just the overlapping n-grams, not just one or two of them, but how many more of them happen with a bigram, or what about the longest common subsequence? And then it does a couple other weighted examples of this. And this is the process of extracting the main ideas or the essence of a text rather than just the details. So similar to Blue, though, this serves an indicator of the similarity based on shared words. And again, if you're struggling at all with this, don't worry about it. We're going to look at a specific example or two in a minute where we're looking at output from these models. So wait, there's more. There's dozens more metrics and new ones that are evolving. And again, I already showed you the other document, and that'll be provided to you. And I very much encourage you to look at these things. I'll say again what I said earlier. For some of you, this session alone is going to be more than you'll ever need. And you never need to look at these things again. You'll say, okay, I get it. That's somebody else's responsibility. That's for my data analyst. That's for my coder. I'm glad I know about it, but I don't need to go deeper. Others of you who are individual contributors are going to need to dive much deeper into the individual metrics. You might even need to pull out some old textbooks from high school or college on some basic statistics, or learn a little bit more about how some of these metrics are calculated. Probably not. Remember, we care more about general outcomes and business outcomes. As fun as it is to dive into some of the technology and as comfortable as it is to work internal with their teams as a product owner, most of us at some point need to get back to the high level and make sure we're getting to the right business outcomes. So let's look at evaluating some of these metrics in real world practice. Has anybody used Google Colab before? Can I see some hands in the chat? Okay, a couple of you are nodding, a couple of you know what it is. Has anybody not heard of it at all? Know what this is? Okay, a little bit of both. So what Google Colab is, it allows you to write and execute Python in your browser. Now, a lot of us as product managers, again, will never need to touch code. And really, we shouldn't be. If we're working at that level, probably we're more of a technical product manager. But for the purposes of just learning, you can go into this thing. Oh, goodness, sorry about that. There we go. Called Google Colab, and I've got links in the I've got links for you to all of these things. And here's a test notebook. And this is pretty simple. If you've never seen this before, the only reason I'm showing you just a little bit about this because I want it to be familiar to you, so you're comfortable going into it yourself. You can just go, hi there. This is a heading, pretty easy. And looks very wiki-like. A lot of us has worked with wikis before. And we can hit shift return. There's the heading, pretty easy, right? And then let's just do the usual hello world in Python, trivially easy, right? And the way this works, this is called a notebook. And what it can do is you can put in text and you can run code. And you do that by hitting this little button here. So we saw that happen in real time. So let's do another one real quickly. Print 2 plus 3, enter 5. So these do things in real time. So you can go to that on your own. Here's a link to it. Here's how to get started with it. Here's the tutorial and another tutorial for beginners on YouTube if you're interested. And what are we going to use that with? Well, we're still going to need some models. We're still going to need some data. HuggingFace.co is one of several communities out there. Kaggle is another really great one that we can go to. And we can go to Hugging Face here. And there are dozens of models that you can pull in yourself. You can get the code for. You can pull in dozens of data sets. And this is absolutely positively overwhelming at first, which is why I'm just trying to give you the basic intro here. You can come here, set up your own free account. And after you do, to use it with Colab, I'll answer that question in the chat in just a moment. You're going to come down here into settings. And over here, there's a place called access tokens. And you can create a new token for yourself. And you're going to use that with Colab. Don't worry about keeping up here because I've left these things for you here in the presentation. So if you want to do this, this gives you the roadmap for exactly how to set these things up so you're ready to run them for yourself, okay? So when you get into, after you get your key in Hugging Face, when you go into Colab, somewhere in here, you'll see a little key on the left side, and you'll see these are your access tokens, and you can say add a new secret. And again, the reason I'm showing these to you now is because I want you to feel comfortable about going into these places and trying some of these things on yourself. We've got a question here. Which metrics are better? The ones we were seeing today in the presentation are the eval scores, relevancy, factual accuracy. Again, it's impossible to say what's better because it always depends on exactly what you're doing. These evaluation metrics are fit for a particular task. For classification metrics, it's going to be one thing. For LLMs, it's something else. For convolutional neural networks, it's going to be something different still. All right. And that's what's in the larger document that you can look at. And you'll be able to see, again, which things are suitable for a particular task. When all said and done, when you're done with all of this sort of mathematical evaluation along the way for the models, what's really going to matter is customer satisfaction scores and the actual user success rate for whatever it is that you're providing. If you're providing something for customer service reps to help people, you know, how much faster did those things happen? Did they actually solve problems? Once upon a time, I worked on a triage tool for nurses to use when they are evaluating patient issues, okay? That's really critically important, right? So how many people tried to abandon that process? How much did it help them in getting people through that system and appropriately to the doctors who needed to, right? So there's different levels of criticality depending on what you're doing, and you're going to have different measures for that level of success. Within the presentation, what you're going to find is links to 4 different Google Colabs that I've built for you guys. And we're just going to look at 2 because we don't have time to go through much more. So this is one of the Google Colabs. In each one of those, what I've tried to do is annotate what each of these sections is. That is, I put notes here as to what each section is doing. So you can skip through most of these. If you're really interested in this, go through every single one of them. If you're not, just scroll right to the bottom. So in this case, we're going to do text categorization and look at the results. We're going to take a corpus of text from a library. And in this case, we're going to use something from Reuters. Reuters is a large news organization. And there's a newswire from the year 1987 that is used for classification and natural language processing and research. Just so you know, as with a lot of things, there are set databases out there in the world that researchers use to test these things. There's things like the Trek databases for search. There are things that have literally been around for decades. A lot of these were built by people. They've been analyzed and vetted for years and years and years to say, this is a ground truth that you can use to build your models upon, because you want your models to be successful with these test sets before you put them out into the real world. So we go through the process of loading the data set and pre-processing the data. And if some of this looks like ML ops, machine learning ops to you, these are basically the steps. Now, if you're not familiar with that yet, somewhere else, I think there was a community session on ML ops. Certainly within the PM exercises course, we certainly go over ML operations, which is critical, machine learning operations. How much you're going to have to do with that is questionable. At a startup where everybody's wearing multiple hats as the product person, you may be helping to define the ML operations pipeline. More likely, this is going to live in IT or development or DevOps or whatever you call your technical engineering group, okay? But you're probably going to be aware of it and involved with it because this is going to impact your work as well, your workflow. Again, if you have P&L responsibility for anything, how you source these data sets, where you get them, how you vet them, how you analyze them, that's going to be part of your responsibility, or someone you work for, or someone who works for you rather, or both. Then we train the model. And in these examples that I'm giving you with Google Colab, one of the reasons I did these this morning or the day before recently, but for now, I've already run all these code blocks because some of them take a long time. A few of them you click, it takes a few seconds. A couple of them might take up to an hour or more. So these results that we're seeing here today are already pre-baked. I did them either a few days ago or one of them I did this morning. So when we get through all of this, here's where we get to, and here's the whole point of why we're here today. We're going to display the quality metrics, and here's the results. All right, let me blow this up a little bit. Hopefully that's easier to see. You guys see that okay? Is that a little better? Okay. So we've got accuracy, precision, and recall. When you're looking at these, you're thinking, well, so what? Is this good or bad? Again, that's always going to be up to you. And you're probably going to be tuning your model and working with your data analysts to figure out how to get these better, depending on what your needs are. So in this case, it's fine to have these numbers. I don't know about you guys. For me, sometimes I like to see the actual results. What does this mean? So in this case, what I did was I printed out the first 20 news wires with human readable labels. So for each of these news stories, there was an actual tag and what our model predicted. And yes, again, we will share from the chat. We will absolutely share the presentation. And yes, 40.48 is not very good. All right. And that's part of the point. Some of the examples here are intentionally bad. That's the whole point. But these things look like they're right. Cocoa, grain, these things all match. So the model seems to have predicted perfectly. But again, this is just the first 20. If you went and change this to the next 100 or the next 200, you're going to start to see divergence here. And why do we care? Well, one of the things we're trying to do is maybe save money on people, right? We're getting all these news stories coming in, and maybe people aren't always necessarily the best at categorizing things, even when people do this. I worked on a project many years ago, and it was sort of Mechanical Turk related, and we had some machines doing it with heuristics, that is with rule-based text, trying to do word stemming and categorizing. And then we had 2 or 3 or 4 different people from around the world also categorizing, and they were rarely coming up with the same answers. So we would index these things together, come up with a score, and just an escalate or elevate things that matched well. And then some things that didn't do well at all, we would put them into another bucket and analyze them separately. So sometimes you'll do well, sometimes you won't. The other thing that you're going to find in these examples that I'm offering you is text versions. So what I did was I copied the output and I just put it in text. And the reason why is because if you come to these things and you go up here and you do copy into your own notebooks, they'll be raw. And if you have any trouble running them, I wanted to make sure that my output was available to you just to read. So if you don't feel like running the code, if it's not something you're interested in, you can just look at the results. So we're going to look at one more of these. Again, there's 4 in the original. Oh, so there we go. Runtime disconnected. That's why I tried to put in the final results, because sometimes Google's going to disconnect you. So this is another set of scores. Again, we're going to use the XSUM database, which was used in a different example. And this is BBC, British Broadcasting articles collected from 2010 to 2017. So there's a lot of these collections of things out there that people have very generously offered up to Hugging Face or elsewhere that we can use to test if we want to play with these things. All right. So all of these things get categorized into news, politics, sports, weather. And we want to be able to do this automatically because we've got new news stories coming in, and we don't want our people necessarily categorizing these things. We want them to quickly go into our database and up to our news site, and we want to do it with a high degree of confidence. So what is the Meteor score now, as distinct from Rouge or Blue? Well, somebody came up with what they think is a better way to evaluate these things. And what they're trying to do is consider things linguistically, like synonyms and stemming. So again, we go through the MLOps procedures of installing all of our libraries. We split up the data sets. And by the way, I didn't necessarily use validation data here. I just went, straight from training to test, just for speed's sakes. And we're going to generate predictions. And this is another example. If you do this on your own and you use this example, this might take an hour to run. Okay, so get some lunch. It's not just a coffee. It's going to take a while. Once we get all of these things, now we're going to generate a whole series of evaluations, the Rouge, the Blue, and the Meteor scores. And these library functions here just can generate the scores. They're not going to show them to you, but you actually want to see them. All right, so we're going to print them out. And see, this is a bad example. I ran this earlier, but for some reason, there it is. Okay. So I have to run. If something doesn't run, like this code block, it means chances are I got to go up and run some of the prerequisite code blocks. And we're not going to sit here and do that because it will take too long. So I'm not going to try and rerun this run now because it might not come out right. I'm just going to look at the thing I ran before. And this gives us the scores. And if you're looking at these scores, even if you don't know anything about these scores, you're probably thinking, these kind of feel low. You'd be right. Okay. So what does it tell us? This model isn't necessarily working. Now, it could be the model, or it could be the hyperparameters. Let's remember, hyperparameters, it seems like a fancy word. Maybe it's outer space or something. No, they're just parameters that sit on top of our model, hyper on top of. So the model itself is supposed to get us close to where we want to go. But hyperparameters, again, which you'll learn about in other sessions of this course, the PM exercises course, whether it's temperature or how many epochs you're going through or what the batch sizes are, those can all impact what these results are. Or you might just have a bad model altogether. Or the data set is not appropriate for this model. Or you need to fine tune the model, right? So there's a lot of different pieces that could come into play here. And for you as a product manager, why do you care? Well, because you care about outcomes, and because all of these things are going to be a matter of time and money. You've got X number of sprints to get to your product. You've got a large scale product plan. And even though, as we all know, technically speaking, on a roadmap, it's maybe not supposed to have dates. We're all being called to the carpet to get something done in a certain amount of time. And if you're burning sprints with bad results, that's unfortunate. So some of the decisions that you're going to need to make with your data analysts and scientists is going to be how close do you need to get to quality to get something to market. So let's look at a specific example here now. Here's one of the documents of the news stories here, right? So it's talking about different people apparently being charged with hate crimes. It's rather horrible, and how they were denied bail. And then two things happened here. This was a reference summary written by a real person. There's 4 people accused of kidnapping a mentally disabled man. And I apologize for, I didn't pick this example. It just spit out from the news, have been denied bail. So that's the reference summary. And this is the one that our model generated. And it talks about the 4 people that are getting charged. And that's pretty good, actually. So this kind of means the same thing. So that's not bad. So we're looking at real world examples of how this particular model in code that we got from Hugging Face for free, running against another free data set, got evaluated. And here's my summary of what this is. All right, so this shows what the scores were and whether they're good or bad. Okay. And the point of me showing that to you again was not necessarily to take you through every detail of each of those things, is to offer you this presentation and these links to drill into those with plenty of time on your own to play with them. And you can look at the code, and if you already know Python, it'll be very clear to you. If you don't, it's annotated and it tells you what each block is doing. And it's a great place for you to play around a little bit. Now, remember, you can always take those code blocks and put them into ChatGPT or Claude and say, could you please adjust this and do something else with it, all right? So you can build these things on your own using Colab, even if you're not necessarily a coder, which is great, which is part of the purpose for it. So what about, let's see here. Let me just see if there's any interesting questions here. I was part of the cohort, and will I still get? Yes, the links to the doc will all be there, as I said. If it's not a foundational model, is there a point in measuring blue or rouge? Whatever the final ensemble is where you're going to measure it. And if it's coming out poorly, you may have to go back to the foundational model, or you've chosen a bad foundational model for the data set in question. Okay. So yeah, I think there is a point to that. That's a conversation you're going to need to have with your data analysts and data scientists that are working on the output for you. What about embedding models? Is blue and rouge the way to measure those two? Same answer. Okay. I'm not sure what those refer. Oh, no, it's just Aretha. Okay, that's somebody's name. Got it. Anyway, hopefully that answers those questions. If not, pipe up in the chat. So let's take a really high level view for a moment of what these tests do. Mathematically, for a lot of these things, we're basically fitting a curve to a function. And you go back to high school, what was it? Y equals mx plus b is a straight line, right? So if you look at a scatter plot, you're trying to figure out, is this linear or nonlinear? Maybe it doesn't fit a curve, all right? And your metrics are going to come out poorly, and you need a better model. But what a lot of these models do are essentially just trying to fit something to a curve so you can get predictive capability about some sort of new data that's coming next. That's for a lot of the regression or classification type things. Now, when it comes to things like LLMs, that's a lot harder. Whether it's decision trees or rule-based models, clustering, ensemble models, reinforcement learning, it's not so much about curve fit. In these cases, we're looking at how effectively the data gets partitioned or optimized and makes decisions. So I think there's a lot of things that are happening now where people are still trying to figure out how to measure these things. And this is why we've seen some fairly catastrophic failures in the marketplace, right? We've seen some things come out from very large companies. They clearly had bad data, bad bias, bad so-called hallucinations of things, and yet they released these things. All right. So you also have to look at your risk profile. It's one thing for a start. Now, nobody should be releasing bad product, and certainly if you're in a high-risk area like medicine, please don't. But there's a difference between, a startup that's trying to classify some news articles or something like that, and a major large company that has brand reputation risk doing something in either medicine or just in general text generation. And we've seen that in the marketplace. So, and this is why we're increasingly seeing observability platforms. Back in the day, originally, when the web first got invented, everybody had to count on their own. You looked at your log files. How many page views did I get? What came next? Well, then we got business intelligence tools, web and mobile and social tools in the form of Google Analytics, of course, Mixpanel, Adobe Analytics, a great many others. Then, of course, what came next? Things like IoT, Internet of Things, Web3, blockchain, more tools, more analytics tools, some of the original players out there, and then new ones like chain analysis and coin market cap. Let's keep going. Finally, where are we today? We've got ML and AI, and now we've got things called observability platforms, which arguably the reason they call them that is because they're potentially a little bit deeper than analytics, because they're not meant to be just lagging indicators of what happened or figuring out what our analytics are. They're trying to figure out, are things okay in real time in production right now? Is something going wrong? Is there drift? And these tools are all over the place right now. As in the past, we're going to see the battle of the checkboxes. When I say that, I mean, we've all seen those feature boxes where everybody checks a box. I have this feature, you have that feature. This is what it costs. This is what this one has or not. So a lot of these tools have some of the same core features, but increasingly they're going to try and differentiate themselves. Why do you care? Again, you might have responsibility for helping choose some of these tools, all right, or paying for some of these tools out of your budget. So let's end near where we started. You personally might not own this task. It could be a direct report of yours if you're a CPO or VP of product. You might have a whole team that's dedicated to this, and they handle all that for you. Or it could be managed by another department. It could be your product, and all of this sort of thing happens in a data analysis department if you're a larger company. Or maybe it's happening as part of development, and it depends because we're all at different levels of maturity as we move into these new spaces. But as a product manager, it's most likely true that you're responsible for business outcomes, all right? And certainly as you move in your organization to more strategic roles, that's increasingly going to be true. If you're a functional product, if you're a technical product manager, as an individual contributor, that's one thing. As a product owner, that's another. As a product manager who's looking outward at the world and maybe has responsibility for some parts of marketing aspects, that's another perspective. But certainly, the moment you get into any type of P&L responsibility or outcome responsibility, you do care about these things. You might, again, I think I've said it 3 or 4 times already, so I'll say it one last time. You might not need to know deeply about some of these metrics, but you need to make sure that somebody is paying attention to them because it's going to make a difference about your goals. And I think it's increasingly going to be part of your world. That's about it. We do have a few minutes left. So, if anybody's got further questions, please go ahead. Let's see. Give an example of performance metric you measured in your actual projects. How did you work with your data science to improve it? All right. In the case of the examples I've given you here, these were all me. No data science involved. On other projects that I've worked on, again, I was lucky because I had a group to do that. And for convolutional neural nets, for example, I'll be perfectly candid with you. I'm not sure exactly what evaluation metrics we used. I saw the percentage improvements, and that was that in that particular case. In other cases, I worked closely with them to figure out which things were most important. And when we got to the highest level of scores and the customer satisfaction scores were good at the output. But examples of user feedback that's driving the model fine-tuning. Could you please give me an example? Do you have any examples of actual user feedback that's driving the model fine-tuning, focusing on accuracy, precision, and recall? I'm sorry, I don't. Not for my particular projects and not for these examples. I think that the answer here is ideally, nothing's getting all the way out to the user without already having passed some base level stage gates of having acceptable answers here in the first place. Now, if it turns out that user satisfaction scores in general are low, and you go back and these other numbers are high, you've obviously got a different sort of problem. The only other thing I could tell you about that, again, not having specifically done it, is that if you're getting poor scores there and something's happened in the world where the data that's being consumed has changed, you might need to rerun those analytics and you might see that they've gotten lower. All right. At that point, whether you need to, how you need to fine tune or use RAG or something else, that's going to depend on the situation, obviously. Any metrics on measuring model drift, model bias, parity? There are. They're in the other document that you can click on go to. My understanding, I have not personally been involved with measuring specific drift of, say, for example, LLMs. I've never personally done that. So I can't speak to you about that from a position of any type of deep expertise. My understanding, insofar as I've looked at it, is these things are still in the scent. These things are still kind of new, all right? And there aren't really great examples for this. There's plenty of examples in the real world. We can look right now. Look at US elections, for example. You know, you had somebody running for president and then who that was changed. That's kind of a drift change. If you were asking questions about who's running for president, there's a certain date at which that changed radically, right? Are the answers going to be coming out correctly? And things like that happen all the time. Remember, we have ambiguity in traditional search. Bass is a favorite example of mine. Bass could be the shoe company, Bass Sal. We have bass guitar. So there's all these different things where there's potential ambiguity. And if something becomes popular in the news or in literature or in the corpus of data that's being consumed in the first place to generate results, there's going to be drift. So I don't know the answer to your question. I know it's going to be increasingly important. I don't think anybody's really solved it yet. That's about it. Jacqueline, anything else? Any other final comments or questions?
Oh, thank you so much, Scott. You did an absolutely amazing job. I learned so much, and it was really nice learning from you. I appreciate you taking the time out of your day.
Oh, it's my pleasure. It's been a lot of fun.
It was
Again,
awesome. Yeah.
so all you guys, look for the postings of the actual course materials. Please dive deeper. If you see any issues with them, my LinkedIn link is up there. Just ping me on there and let me know if you saw any problems. And thank you so much for coming.
Of course. Yeah. And just a friendly reminder, if you're considering becoming an AI product manager, I put the link to our upcoming program in the chat so you can easily click that whenever you get a chance.